All right, so I believe it's time for me to go ahead and get started. So nitrogen management in hemp production. This is Citra. We have three locations in Florida: Homestead, Citra, and Panhandle J. We have PIs from Homestead, Dr. Brim, and the PI from J, Dr. Hardeep Singh. So all these three locations are basically replicated the same trial with same varieties. The difference between these three locations is the management schemes, planting, because of the limited resources on the planting. We are using different planters and all that. Some of the locations have unique issues like fire and flooding. So that actually helped us in learning more about hemp. So I'm going to go ahead and start with my presentation. Navdeep Kaur, my master's student, helped me preparing this presentation. So I would like to give a few tries to her. All right, so hemp is an annual herbaceous. I think I asked the question in your pre-quiz, pre-presentation quiz, grown for seed fiber and cannabinoids. Legal cultivation started in 2018, and very limited research is available. Most of the guidelines that you will see on the nutrient management on IFAS website are basically compiled by Dr. Brim and the co-workers, looking at the different states, because I think Colorado is pretty advanced in developing those recommendations and cultural practices objectives. So the objective of hemp research in Citra was comparing different nitrogen rates. We have rates from all the way 0 to 250 pounds per acre. I would be mostly focusing on the units that we commonly use here, because our audience is also mostly from United States. We also covered the effect of N rates on nitrate leaching. You all saw those lysimeters that we have added under the plot. So we taking out all the leachates every 20 days. Thank you to the research team working in this. Sometimes I call it unimaginable heat and humidity, to take all the samples and send it to the lab for analysis. So these are the objectives of the research. So this is the location you are in. Mostly this is fenced and monitored. There's a camera there. The seed rate, you can see 200 and almost 200,000. I'll go that way. Experiment design RCBD, their N rates, they are kg per hectare. But if you want to convert it to pounds per acre, it would be all 0, 50, 100. Other nutrient that we used, 61 kg of P2O5. I would like to make a note for people who works on nutrient management. This is P2O5, not P. P and P2O5 is around 45 to 46%. And micronutrient blend applied as a split at sowing around 35 days after sowing. So an application was a split application. It was not a one-time application. It was 20% at the planting. We call sowing at many places. 30% 20 days after planting, and 50% of 40 days after planting. So it was a split, 3 splits that we used for this study, and it was plain urea nitrogen source, because we don't want to compromise any other source to play another variable here. This is a field experiment layout for the lysimeter trial. The boxes, the blue boxes you see here are the lysimeters. This is how the lysimeter, somebody asked me how the lysimeters were installed. So I was explaining them. We basically use excavator to dig out a huge hole on the ground and install those lysimeters. So this is basically a picture of how we use the excavator. And we tried our best to use this compaction to address the compaction issue, to address the soil disturbance, but believe me, it was a huge soil disturbance. and the data we collected within that 1 year was everywhere. So I would not trust any data that's coming out of this kind of lysimeter installment for the first year. But we saw very consistent data the next year. Dr. Hardeep Singh presented the data yesterday in the cotton rate study. We had a wonderful result on the leachage. All right, so grain nitrogen grade trial emergence percentage. So you saw that the percentage is pretty much around roughly 60% on average across the rates, but we saw a difference in as the rates are going up, we saw a difference in percentage. So that may be, again, I'm saying maybe because we do not have a concrete data to say firmly. So it's 2021 data that nitrogen is impacting the emergence. But there is definitely what happens when the nitrogen source get dissolved in the soil. It basically lowers the pH. It's acidic acidic fertilizer that releases the hydrogen ion and it reduces the soil pH. So that may be one factor that is playing here, but we saw a change in germination percentage as we are applying nitrogen rates. And you can see the beautiful plants on the right-hand side on the slide, the hemp. No weed issue at this moment. All right, so this is the difference in nitrogen rates. You can see a beautiful picture with the different nitrogen rates. And you saw on the in this graph, the x-axis is nitrogen rate and y-axis is the crop height. And as the nitrogen rates are days after planting are increasing, you see the height of the plant is also increasing. So the gray line is here, 91 days after sowing. Sowing and planting are exchangeable terms here. And you can also see that there's a trend as the nitrogen rate is increasing, the height of the plant is increasing. But there is a plateau at some point. So we can make some sense because crop height is used as one of the factors in developing recommendation in many places. So we can use this as a factor, and we have a plateau. So this would be used as a guiding factor for us to develop recommendation for nitrogen moving forward. Here, TTN, total nitrogen. For some reason, I have a hard time to spell that name, whatever. Nitrogen is the total nitrogen, I would say, that has ammonia, nitrate, nitrite, all together. And on the x-axis is the N rate, and you can see that it's increasing in the plant tissue as the nitrogen rates are increasing. But somewhere around 168, the curve is moving down. There's a plateau there. So what that means is that after that, whatever you're applying, it is basically impacting your yield negatively. So that's what we call plateau. If you do not understand a word that I'm saying, please raise your hand. I'll be able to rephrase my statement. Thank you. The phosphorus rate. So here, that's a good news, but the DEP folks are already left. So, folks, the phosphorus we didn't see any response of phosphorus in hemp. There are two outcomes. One is obviously we have sufficient phosphorus in our soil, and which is again fixed or bound with aluminum, iron, calcium, depending on the pH range. The second outcome is that the hemp is pretty good at extracting that phosphorus out of the soil. So in both ways, it's a good news for our regulatory agencies that hemp may not need additional phosphorus from the fertilizer. So could be a commodity that many people are going to like in that terms. All right, that's how the seed looked like. We're trying to look at seed in the field today. It was not ready, it's kind of a milking stage. But on the left-hand side of the slide is the dry biomass. On the y-axis and x-axis is the end rate, and you see that there's an increase in biomass. So obviously the biomass is required in many ways to learn about the fiber total fiber content, the seed yield, because that seed going to be used for oil, seed oil. So it is also found increasing, but you saw there's a huge variability in the data, and that variability is because a lot of factors. Weeds. We have a huge issue of weed in hemp production because there is no certified herbicide that we can use. There are herbicides that people are using. We have some success. I was talking to Dr. Singh today. There is a herbicide they are using that's not impacting the hemp plants. So some of the options that we have, we do need a weed scientist that can help us moving forward. But we are also looking across the nation if somebody has already developed some herbicide that we can use. But in Florida condition, if you do not have an herbicide and you have a rain every day, it's very difficult to manage weeds. Thank you, Dr. Brent, for getting us a seed extractor. I think there's a name for it. Thresher. We used this combine last year, and in 2021 was not highly efficient, but we tried with the tools we have. I would say it had a good efficiency around 70%, and 30% we lost seed. But now we have a thresher, so we have a specific thresher for hemp. But we have a positive response, and that's what I'm trying to say here, that we have a positive response of not applying nitrogen in the biomass and seed. All right, NDVI. So NDVI has been used successfully in determining or estimating. There's a term many people use as I determined the nitrogen requirement. I would more cautious saying that term because it's an estimation. I do not know exact. NDVI is again a predictor, not directly analysis from the lab. So it's an estimation of nitrogen requirement. So you can see that the 21 days after sowing and 50 days after sowing, the two different correlate regression curves. And this is a pretty good relationship here, around 75% square and early. So hemp at early stage is very small. And if you have a weeds, it don't interfere with your NDVI data. So because the NDVI sensor cannot detect hemp or a weed, it basically takes your NDVI readings from the biomass that is on the ground. That could be a weed green biomass or a hemp biomass. So we're trying as much as we can to avoid the weed data. But once the hemp is up and running, like it has a good height around 4 feet, 3.5 feet, it basically kills all the weeds. It's an invasive species, and it compete with the weeds and basically kill the weeds. So in that case, we have a very good relationship here, and we saw that the data is pretty lined up close to the line. That tells us a boundary and a robust data there. Same for NDRE. The NDRE is another vegetative index. It's called red edge index. It's close to NDRE. NDVI is just another vegetative index. We tried both. Both were very good in determining the correlated with N rates. Okay, so above ground biomass and seed yield here, you can see that not a huge significant difference between all the way 112 and 168. So the levels that are same on these bars have no significant differences. I just want to make sure that people who do not have a huge statistical background, the same letters, if the two bars share the same letter, that means there is no significant differences. So far, there was a difference between control and rest of the treatments. So that means applying nitrogen do help improving the biomass yield. But what treatment is the best? We need more data to determine it. So same for the seed yield. There's a difference between control and 224 pounds of nitrogen. But we need more data, more year data to confirm that that's where we are going. All right, so nitrate leaching in water. I try to look at that data. Obviously, I said that the first year we do not, trust that data a lot because there's so many outliers. We disturb the soil, and but we kind of have some insight into the nitrogen rate and leachate. So 0 is a control, 168 kg per hectare of nitrogen, and 280 kg per hectare of nitrogen. And you can see as the rates are increasing, the leachate nitrate in the leachates is increasing. So this so I think today's presentation of 30 minutes or 20 minutes.
20 minutes.
30 minutes. Today's 30 minutes.
20.
Yesterday was 20.
Okay.
So
then you have 15 minutes.
Perfect. I have 15 minutes to go over. All right. Thank you, Michael. But it was a good heads up. So, and you see that the lysometer do work in some situations when the groundwater is not interfering. We have data from other stations that where the groundwater is interfering with the lysometers, and the data basically moves everywhere. But I had more confidence from yesterday. Dr. Singh presented data that lysometers could be used in Florida. Okay, experiment 2, Bioprosesky. The first experiment was on lysometer rate study. This is another variety, pretty much the same rates used in this variety, so I don't want to go over all the rates. The same number of splits being used, same amount of splits being used in there, and same amount of phosphorus and potassium being used here. This is the layout for this experiment. RCBD, 4 blocks, randomized complete block design. This is the germination percentage. You can see that we saw a good relationship between the germination percentage and end rates in one variety, but in this variety, there's not a huge trend. So as the variety of genotype is changing, the hemp variability changes a lot. Here is a plant height. We saw typically the same trend in this variety as well as we saw the other variety in lysometer trial. And similarly, the second stage where we measure the height, which was I forgot the days after here. But anyway, so here both times the relationship was pretty strong. And that means that the end rate do help improve the height of the hemp plant. And you saw in the field, the height of the control plots was much smaller than the higher end rates. So that way, it makes there is an outlier out here. So we're basically using all the data we have. We did not polish the data yet. All right, dry biomass and seed yield. Similarly, x-axis end rates and y-axis biomass and seed yield, and there was a high correlation between the two factors. I believe you all know that the x-axis here is an independent variable and the y-axis is a dependent variable. So the y is dependent on x, so there's a good correlation between these two factors. It's a Bioprosesky and X56, the two varieties that we use here. Layout for the phosphorus rate study, I think I mentioned here, and we also looked at it in the field. There was no response in phosphorus rate across the plant yield or height or plant biomass. So we're confident that applying more phosphorus is not helping improving plant health in hemp. And again, this is first year data. We need to confirm it. We have the trial this year. We will analyze the data after harvesting and we will confirm it. Conclusion. So based on these results, we can say that we can grow we can use hemp for the grain production, and it has a great potential in Florida sandy soils. But one thing, we do not have any processing industry in Florida presently. And I think I did mention in the morning hours that I was last week. I was on a horticulture conference, and Texas got a huge new facility, processing facility for hemp fiber. So finger crossed, maybe someday we will get in Florida. Plant growth, biomass production, grain yield, and depends on end rate, and also on the variety. So the variety is a huge factor. You have, I'm sorry, I was distracted by Hayden. All right, so variety has a huge factor on the germination and overall health of the plant. Some varieties performing really good in some places. We have 3 different locations across Florida, and we are finding different results across Florida. Variety, New West Genetics 2730 performed best at 224 kg per hectare of nitrogen, and variety Bio-Brzezinski and X56 performed best at 168 kg per hectare nitrogen. So it's obviously not requiring as much as nitrogen as our corn plants are, but it's, I would say, a medium nitrogen required crop. If we see compared with on the scale between low and high nitrogen required crops. Acknowledgement. So I would like to say thanks to Florida Department of Agriculture, Consumer Services, Office of Water Act Policy they fund this project for 3 years with Dr. Zach Brim. Thank you, Dr. Brim, for having us as a co-PI. And we got renewed that project, so thank you again. I would like to say thanks to Navdeep. She worked on this project really hard. Wendy Griffin, my bioscientist, she helped in organizing this BMP summit, and also is a key partner in the hemp production and the hemp research. Brendan Burns, we have so many success stories. Brendan is now working for the soil lab in ARL soil lab in Gainesville. Holden moved to New Jersey. Yes, he worked with us for 2 years. Hayden was on OPS when he started, and now he's a master's student. Simran, Aman, Mokum, Buck. I would like to say thanks to Buck. He did really good in helping us running the trial on the station. Jerry and Jim Boyer for your leadership. All right, I'm ready for questions.